sine of a plus b plus c, which we have done already. This is equal to sine of a cos b cos c, sorry, this is equal to sine of a cos b cos c plus sin b cos c cos a plus sin c cos a cos b minus sin a sin b sin c. Similarly, you can find out cos of a plus b plus c is equal to cos a cos b cos c minus cos a sin b sin c minus cos b sin a sin c minus cos c sin a sin b. Similarly, you can find out tan of a plus b plus c this is equal to tan a plus tan b plus tan c minus tan a tan b tan c whole over 1 minus tan a tan b minus tan b tan c minus tan c tan a. Now sine of a1 plus a2 plus a3 and so on plus an is equal to cos of a1 cos of a2 cos of a3 so on cos of an into s1 minus s3 plus s5 minus and so on, where this s1 is the sum of the tangent taken one at a time, like tan of a1 plus tan of a2 plus so on. S3 is tan of a1 tan of b1 plus tan of a1 tan of, sorry, this is not b1, this is a2 and then tan of a3 plus tan of a1 tan of a3 tan of a4 and plus so on. Now for cos of a1 plus a2 plus a3 plus so on plus an is equal to cos of a1 cos of a2 cos of a3 so on cos of an into 1 minus s of 2 plus s of 4 minus s of 6 and plus so on, where s2 is sum of tangent taken 2 at a time, tan of a1 a2 tan of a1 tan of a2 plus tan a1 tan a3 plus so on. Now Similarly we can find tan of A1 plus A2 plus A3 plus so on plus AN. This is equal to S1 minus S3 plus S5 minus so on over 1 minus S2 plus S4 minus S6 and plus so on. Now suppose that in this formula, if A1, A2, A3 and so on AN all becomes equal, that means if A1 is equal to A2 is equal to A3 is equal to A4 and so on, then sine of NA becomes cos of A N into S1. Now S1 will become N tan A and S2 will become NC2 tan square A. S3 will become NC3 tan cube A. Therefore, this S1 will become N tan A and then this S3 will become NC3 tan cube A plus NC5 tan 5 A and minus so on. Similarly, you can write cos of N A is equal to cos raised to power N A into NC1 tan 1 minus NC2 tan square A plus NC4 tan 4A and minus so on. When you find this tan NA, you will just divide these two terms, sin NA over cos NA. This cos NA and cos NA will be cancelled out and you will be left with N tan A minus NC3 tan cube A plus NC5 tan 5 A and so on whole over 1 minus NC2 tan square A plus NC4 tan 4A minus and so on. Now some more formulas are sine of 60 minus A, 60 degree minus A, sine of A and sine of 60 plus A. This is equal to 1 by 4 sine of 3A. You can use this formula directly. Similarly, cos of 60 degree minus A, cos of A, cos of 60 degree plus A. This is equal to 1 by 4 cos of 3A. Similarly, tan of 60 minus A, tan of A and tan of 60 plus 8. This is equal to tan of 3A. Suppose if you have cos of A into cos of 2 raised to power 1 A into cos raised to power cos into 2 raised to power 2 A into cos 2 cube A and so on, cos 2 raised to power n minus 1 A, then this is equal to sine of 2 raised to power n A over 2 raised to power n sine A. Suppose if you have cos of pi by 7, cos of 2 pi by 7 and cos of 4 pi by 7, then you can relate this formula with this question. Here A is equal to pi by 7 and n is equal to, see, this is 2 raised to 1, this is 2 raised to 2 and this was 2 raised to 2n minus 1. That means n will be equal to 3 here, and this will be equal to 1 by 2 raised to power 3 sine of 2 to the 4 to the 8 A over sine A. Now what is A here? A is pi by 7. So you will write down pi by 7 in place of A. This will become 8 pi by 7 over sine of pi by 7, and this will become 1 over 8 sine of pi plus pi by 7, and this will be equal to over sine pi by 7. Now this will be equal to 1 by 8 sine pi plus pi by 7 will be equal to minus sine pi by 7, because pi plus theta which lie in third quadrant, and in third quadrant only tan and cot are positive. That's why sine will be negative. This will be sine of pi by 7. Now this sine pi by 7 will be cancelled out and you will left with minus 1 over 8. Now, sine of alpha into sine of alpha plus beta Now we will find out maximum and minimum value of a trigonometric function. Of type A cos x plus B sin x. Now what will be the maximum value for this trigonometric function? To find out maximum and minimum value of this kind of function, first of all we will write down this function in terms of a single trigonometric function by making the substitution A is equal to r cos theta and B is equal to r sin theta. Now put this value here, you will get r cos theta cos x plus r sin theta sin x. And you will get r cos of theta minus x, where r is under root a square plus b square. This you can find out by taking these two equations. Here cos theta is equal to a over r and sin theta is equal to b over r. When we will substitute these two parameters in the equation, sin square theta plus cos square theta is equal to 1, you will get a square over r square plus b square over r square is equal to 1. That means a square plus b square is equal to r square, or r will be equal to under the root a square plus b square. So now we know that cos theta always lie between minus 1 and 1. That's why if you multiply this by r, then this will be equal to minus r less than equal to cos of theta minus x less than equal to r, where r is under the root a square plus b square. So this will be equal to minus under the root a square plus b square less than equal to cos of theta minus x less than equal to under the root a square plus b square. So the minimum value of this function is minus under the root a square plus b square. This is the minimum value, and maximum value will be plus under the root a square plus b square. This is the maximum value of a trigonometric function of type a cos x plus minus b cos x. Or similarly you can prove for a cos x minus b sin x. Maximum and minimum value for this function will also be same, as minus root a square plus b square will be minimum value and plus under the root a square plus b square will be maximum value. Now we will start trigonometric equations. Now what are trigonometric equations? Any equation which involve trigonometric function, that is called trigonometric equations. And like every equation has a solution, trigonometric equations also have solutions, which we can classify into two categories. One is principal solution, and the other is general solution. Now, what is principal solution? Principal solution is the least angle which satisfy a trigonometric equation. And general solution, since you know that trigonometric functions are periodic functions, that's why general solution is the all value of angle which will satisfy the trigonometric equations. Now let's try some formulas for different trigonometric equations. Now first of all, suppose you have sine theta is equal to 0. Here we know that sine theta is equal to 0 for all plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. Therefore, we can write sine theta is equal to sine of n pi, where n belongs to integers, because sine 0 is 0. That's why 0 will also be included in between plus minus 1, plus minus 2, plus minus 3, and so on. In a similar way, cos of theta is equal to 0. Now we know that cos theta is 0 for all the odd multiple of pi by 2, like pi by 2, 3 pi by 2, 5 pi by 2. Also, this is equal to 0 for all minus pi by 2, minus 3 pi by 2, and so on. Therefore, solution for cos theta is equal to 0. So here we can conclude in the above case theta is equal to n pi, and here we can conclude that theta is equal to odd multiple. Any odd number can be represented by 2n plus 1. So this will be equal to 2n plus 1 into pi by 2, again where n belongs to integer. In a similar way, if tan theta is equal to 0, now theta is again 0 for all multiple of pi. Therefore, again we will write theta is equal to n pi, where n belongs to integer. This was the general solution for sin theta equal to 0, cos theta equal to 0, and tan theta is equal to 0. Now we will try some more formulas. Suppose sin theta is equal to sine of alpha. Now, taking sine alpha on the left hand side, we will get sine of theta minus sine of alpha is equal to 0. Here we will apply sin c minus sin d, which was equal to 2 sine. This is sin c minus sin d, which was equal to 2 sine c minus d by 2 cos c plus d by 2. By putting this formula, by applying this formula here, 2 sine of theta minus alpha by 2 cos of theta plus alpha by 2 is equal to 0. Now since 2 is a number, therefore it cannot be equal to 0. That's why sine of theta minus alpha by 2 cos of theta plus alpha by 2 will be equal to 0. Now here either sine theta minus alpha by 2 will be 0 or cos of theta plus alpha by 2 will be equal to 0. So this will be divided into two cases. One is this, or cos of theta plus alpha divided by 2 is equal to 0. Now we have done sin theta is equal to 0 when theta is an odd multiple of, or you can say odd or even when sine is multiple of pi. That means theta minus alpha by 2 is equal to n pi, where n belongs to integer and theta minus alpha is equal to 2n pi. Theta will be equal to 2n pi plus alpha. Now we know that cos is equal to 0 when it is an odd multiple of pi. That means when theta plus alpha divided by 2 will be equal to 2n plus 1 into pi by 2. This 2 will be cancelled out and you will left with theta plus alpha will be equal to 2n pi plus pi, or theta is equal to 2n pi plus pi minus alpha. Here you can say that theta equal to, again taking pi common, 2n plus 1 pi minus alpha. So from these two conclusions we can show that for sin theta is equal to sin alpha, theta is equal to n pi plus minus 1 raised to power n alpha, because here angle is a multiple of even multiple and here angle is an odd multiple. That's why theta will be equal to n pi plus minus 1 raised to power n alpha. Now in a similar way, when cos of theta is equal to cos of alpha, then cos of theta minus cos of alpha is equal to 0. Cos C minus cos D is minus 2 sin theta minus alpha by 2 sin theta plus alpha by 2 is equal to 0. We will do the same thing which we have done in the earlier question by taking either this is equal to 0 or this part is equal to 0. That is, either sine of theta minus alpha by 2 is equal to 0 or sine of theta plus alpha by 2 is equal to 0. Now for this one, theta minus alpha over 2 is equal to n pi, which will be equal to theta minus alpha n pi to n pi, and theta will become 2n pi plus alpha. Similarly, for sine of theta plus alpha divided by 2 is equal to 0, theta plus alpha by 2 is equal to n pi, and theta will be equal to 2n pi minus alpha. By combining this one, this result and this result, which is number 2, by combining 1 and 2 we will get theta is equal to 2n pi plus minus alpha. So this is the general equation, general solution for the equation cos theta is equal to cos alpha. Now similarly we will prove this for tan of alpha. This is tan of theta minus tan of alpha is equal to 0. Now from here you can do this in two ways, either by applying tan formula or by open this in terms of sin theta and cos theta. This is sin alpha over cos alpha is equal to 0. So here you can write sine of theta cos of alpha minus sine alpha cos theta whole over cos of theta cos of alpha is equal to 0. This is sine A cos B minus cos A sine B. So this will become a formula sine A cos B minus cos A sine B, which is again equal to sine of A minus B over cos theta into cos alpha. Now we know that any rational number is equal to 0 if its numerator is equal to 0. That's why sine theta minus alpha will be equal to 0. Now this will be equal to 0 when theta minus alpha will be a multiple of n pi, where n belongs to integer and theta will be equal to n pi plus alpha. Thus from here we come to the conclusion that whenever we will have sine of theta is equal to sine of alpha, we will write theta is equal to n pi plus minus 1 raised to power n alpha, and whenever we will have cos theta over cos alpha, then theta will be equal to 2n pi plus minus alpha, and the last one tan theta is equal to tan alpha, then theta is equal to n pi plus alpha. Now we will do some more trigonometric equations. Suppose if we have sin square theta is equal to sin square alpha, then we will write 1 minus cos 2 theta over 2 is equal to 1 minus cos 2 alpha over 2. This 2 will cancel out. We will left with 1 minus cos 2 theta is equal to 1 minus cos 2 alpha, and this will become cos of 2 theta is equal to cos of 2 alpha. Now we know that cos theta is equal to cos alpha if theta is equal to 2n pi plus minus alpha. That means 2 theta is equal to 2n pi plus minus 2 alpha, and this will become theta is equal to n pi plus minus alpha. So this is a general solution for the trigonometric equation sin square theta is equal to sin square alpha. Now similarly we will prove this for cos square theta is equal to cos square alpha. Now cos square theta is equal to cos square alpha, we will apply the same formula, but for cos square theta 1 plus cos 2 theta over 2, 1 plus cos of 2 alpha over 2. From this cos of 2 theta will be equal to cos of 2 alpha, and again 2 theta will be equal to 2n pi plus minus 2 alpha, and by cancel 2 on left hand side as well as on right hand side, you will get theta is equal to n pi plus minus alpha. Similarly, you can prove this for tan square theta is equal to tan square alpha. Now if this is equal to 1, then applying componendo and dividendo, you will get 1 minus tan square theta over 1 plus tan square theta is equal to 1 minus tan square alpha over 1 plus tan square alpha. Now this is the formula for cos 2 theta, and this is the formula for cos of 2 alpha. Again you will get 2 theta is equal to 2 alpha plus 2n pi plus minus, and you can write theta is equal to n pi plus minus alpha. That means for these three equations, sin square theta is equal to sin square alpha, cos square theta is equal to cos square alpha, and tan square theta is equal to tan square alpha, the general solution will be same, that is n pi plus minus alpha. Now we will write some more general formulas or general solution for the trigonometric functions. Suppose that you have a trigonometric equation a sin x plus b cos x is equal to c. Now, to find the general solution of this equation, first of all, you will convert this trigonometric equation into one trigonometric function only. Multiply both sides by c over under the root a square plus b square. You will get this will be proved by putting a is equal to r cos theta, b is equal to r sin theta, where r square is equal to a square plus b square. Now a is equal to a cos theta sin x plus r sin theta cos x is equal to c. Now this will be equal to, taking r common, you will get cos of theta sin x plus sin theta cos x is equal to c. Now this is sin a cos b plus cos a sin b. This will become sin of a plus b equal to c, and sin of x plus theta is equal to c over r, and x plus theta will be equal to sin inverse, not inverse, sorry, sin of x plus theta is equal to sin of alpha, where sin alpha is equal to c over r, and then we will apply the equation sin theta equal to sin alpha. From here, x plus theta will be equal to n pi plus minus 1 raised to the power n alpha, and this will be equal to theta is equal to n pi plus minus 1 raised to the n alpha minus x, or this is x and this is theta. In a similar pattern, you can find some more general solution for the trigonometric equation. Suppose you have a naught sin of n x plus a1 sin of n minus 1 x cos x plus a2 sin n minus 2 cos square x, and plus so on, plus an cos of n x. Now, first of all, you will divide it by cos n x. You will get a naught tan nx plus a1 tan n minus 1x plus a2 tan n minus 2x, and plus so on, plus an is equal to 0. Now by solving this equation, you can find out the general solution for the above equation. For example, if you have 5 sin square x minus 7 sin x cos x plus 16 cos square x is equal to 4. Find the general solution for this equation. What you will do? First of all, let this is 4 into 1. Then you will write down 5 sin square x minus 7 sin x cos x plus 16 cos square x is equal to 4 into sin square x plus cos square x. Now 5 sin square x minus 7 sin x cos x plus 16 cos square x minus 4 sin square x minus 4 cos square x is equal to 0. Now solving this, you will get sin square x 16 minus 4 is 12 cos square x minus 7 sin x cos x is equal to 0. Dividing the whole term by cos square x, you will get tan square x plus 12 minus 7 tan x is equal to 0. Or you can write tan square x minus 7 tan x plus 12 is equal to 0. Now, making factor of this equation, you will get tan square x minus 4 tan x minus 3 tan x plus 12 is equal to 0. That means taking tan x common, you will get tan x minus 4 minus 3 tan x minus 4 is equal to 0. That means either tan x is equal to 4 or tan x is equal to 3. Now here we can write tan x is equal to tan inverse tan inverse 4 or tan x is equal to tan inverse 3. This inverse we will do after this. Here tan and tan inverse will be cancelled out. So this is a general solution, that tan x is equal to tan theta, and for this x was n pi plus theta. Therefore this will become x is equal to n pi plus tan inverse 4, and here this will become x is equal to n pi plus tan inverse 3. So this is how you will solve this kind of questions where a trigonometric equation can reduce to tan Now suppose if you have sin x plus cos x, a function of sin x plus cos x, and you can put a comma here, sin x cos x. For these kind of equations, First of all, you will put sin x plus cos x is equal to t. Then you will find the value of this sin x into cos x. By squaring this, you will get sin x plus cos x, the whole square is equal to t square, and this will be equal to sin square x plus cos square x plus 2 sin x cos x is equal to t square. Now sin square x plus cos square x is equal to 1. Therefore, you will get 1 plus 2 sin x cos x and 2 sin x cos x will be equal to t square minus 1, and sin x cos x will be equal to t square minus 1 divided by 2. Now, putting the value of sin x into cos x in this equation, so this will become f of t in t square minus 1 over 2. Now, you can solve this equation. Now, one more type of equation is here, that is, if trigonometric equation is sin of Lx plus cos of mx plus cot of nx plus tan of Lmn, you can put here tx. For such kind of equations, you will put sin x is equal to 2 tan x by 2 over 1 plus tan square x by 2, and cos x, 1 minus tan square x by 2 over 1 plus tan square x by 2, tan x by 2 is equal to 2 tan x by 2 over 1 minus tan square x by 2, so that this whole equation will convert into tan only. And again, by putting tan is equal to t, you can find out the equation of a simple algebraic equation, and then by replacing t by tan x by 2 or tan x, what will be the angle? You can find out general solution. Now, we will do properties of triangle. That means relationship between relationship between angles and the sides of a triangle. Suppose you have a triangle A, B and C. Now, in this triangle, let this angle be A, this angle be B and this angle be C. Now, opposite to angle A, the side will be small a, this will be small b and this will be small c. First of all, we will derive sine formula, which is equal to a over sine a is equal to b over sine b, c over sine c. This can also be written as sine a over a is equal to sine b is equal to over b is equal to sine c over c. Now, To prove this formula, first of all we will draw a perpendicular from point A on BC. Let this point be D. Now in this case, if we take triangle A, B, D, in this triangle AD over AB, AD over AB, this is perpendicular because angle is here, so that's why this will be perpendicular over hypotenuse, which will be sine of angle B. So this will be equal to sine of angle B. Now AD over, now AB is C, small c. Remember this is small c and this is the capital C. This is the angle, this is the length of the side. So this will be small c is equal to sine of B. Similarly, if we take triangle A, D and C, ADC, triangle ADC, then AD over AC will be equal to sine C. Now what is AC? AC is B is equal to sine of, this is capital C, sine C, because C is the angle. So combining these two results, we can come to the conclusion that AD is equal to C sine B, and from here AD is equal to B sine C. Now since these two are equal, therefore we can write C sine B is equal to B sine C, or you can say sine B over B is equal to sine C over C. In a similar way, you can prove that sine A sine of A over A is equal to sine of B over B. Now combining these results, we get sine of A over A is equal to sine of B over B is equal to sine of C over C. This is your required formula. Now we will derive formula which is cos of angle A is equal to B square plus C square minus A square over 2BC. Now to find cos A, B square plus C square minus A square 2BC, first of all we will write that A B square is equal to BD square plus AD square Now, on a similar pattern, we'll prove this later on. Sorry. Cos B is equal to C square plus A square minus B square over 2AC, and then cos C is equal to A square plus B square minus C square over 2AB. Now to prove this formula, we will write that in a right angle triangle, AB square is equal to AD square plus BD square. Now AB square will be equal to AD square plus, now what is BD? BD is BC minus DC the whole square. Now this will be equal to AB square is equal to AD square plus BC square plus DC square. You can put a bracket here, not to be confused, minus 2 BC into DC. Now this will be equal to AB square is equal to AD square plus BC square plus DC square. Now put this in a separate bracket, AD square plus DC square plus BC square minus 2BC into DC. Now this is equal to AD square plus DC square. This is AD square plus DC square. Now since this is 90 degree, therefore AD square plus DC square will be equal to AC square. So you can write here AC the whole square plus BC square minus 2BC dot DC. This is BC and then DC. Now what is DC? If you will find DC, now for triangle ADC, DC over AC is equal to cos of C. That means DC is equal to AC cos C. AC is B, so this is equal to B cos C. This you will put here, and this will become AB square is equal to AC square plus BC square minus 2BC DC. When you put this value here, you will get C square is equal to B square plus A square minus 2 BC is A and DC is B cos C. That is C square is equal to B square plus A square minus 2AB cos C. And by taking this on the right hand side and C square left hand side, and C square on the left hand side, you will get 2AB cos C is equal to B square plus A square minus C square, and cos C, this is equal to B square plus A square minus C square over 2AB. This is known as cosine formula. Similar pattern में you can prove that cos of B is equal to A square plus C square minus B square over 2AC, and cos of A is equal to B square plus C square minus A square over 2BC.